today let's talk about the design process. So, the design process is a really good tool to have as an engineer. The basic idea is it's a generic problem-solving strategy that we can use to try to find a solution to whatever it is that we're trying to tackle. Why make a big deal of this is it's kind of what humans do, right? Is we solve problems, we build things, and that's one thing that sets us apart from many species. Well, my goal here is to train engineers. And engineers are those that apply existing knowledge to try to find practical solutions to practical problems. The truth is, I don't know what kind of problems you'll be solving as an engineer when you go to work. My hope is you'll be building and designing things that don't exist yet and solving problems that I don't even know of. So I can't really teach you how to solve those problems when I don't even know they exist. What I can do is try to teach you how to solve problems in general. And that's the idea behind the design processes. Regardless of what type of product we're trying to design, what kind of process we're trying to improve, no matter what problem we're trying to solve, a similar process can be employed every single time that we do that. Now, so the first step is just trying to figure out what is our problem. What is it that we're trying to accomplish? And that, on its face, is probably going to seem really simple. In what experience will begin to tell you is that doing that well is actually a bit of a challenge. Plan for the design process. So think about what resources do you have available? How are you going to go about using them? What people do you have available? What time do you have available? Do you have a budget? So all of these, and these are really easy to overlook, and a lot of rookies will overlook this step. It's a very important step. And then we go into what we call developing engineering specifications. So a client or a manager or some entity will say, hey, here's a problem that needs to be solved. At this step, this developing engineering specifications, that's where we really sit down and we try to figure out, all right, what is this problem? What is something else causing the problem? Can we, if we fix something 2 or 3 steps up in the process, does that solve the problem? And then the need is no longer a need, then it's taken care of. So what exactly is the problem? How do we measure it? How do we know that it's a problem? How do we know that we're going to have solved the problem? And then from there we get into kind of the next set of steps. So generating ideas. So what are old ideas? What knowledge exists for this problem? We call this researching a lot of times. And there's a step we call brainstorming or synthesis. That's where we generate new ideas. So what are we trying to accomplish? What are some ways this has been accomplished before, and what knowledge exists for this particular scenario? And then how can we put that together in new ways? What are some new ideas or new solutions we can come up with now that we actually know what we're trying to do? Try to figure out, so the idea here is we'll try to generate between the research and the synthesis phase, we want to generate a lot of ideas and try to figure out which of these is the best idea to go forward with. And then from there, try to test it. Is there some way we can test it? Is there some way we can build a prototype or a working model and then move forward with that? So, what we find a lot of times is this is a little more in-depth presentation of the design process. Normally, these first 3 steps will be grouped together. If I'm doing this quickly, what I normally say is the design process looks like this. So the first step is often just simply called problem definition. So we have problem definition, and then that incorporates, if I just simply say problem definition, that incorporates these first 3 steps. What are we trying to do? what resources do we have to do it, what is our time frame, let's develop a plan, and then exactly how are we going to go about doing that. And then you've got this phase that I often call research. That's identify previous efforts, what knowledge exists to try to find a solution. And then you've got this step we call synthesis, right, which a lot of people will call brainstorming. We'll talk about that in a future video. Brainstorming is a specific type of synthesis, but it's not the only way of generating new ideas. And then we've got this phase that we call concept evaluation. That's where we try to figure out which of these ideas that we've seen in the research and or generated in our brainstorming, which of these are going to work, which one do we think is the best one to move forward with, and then proposing, building, testing a final design. Right? So what is it that we're recommending to move forward with? Now, so again, over the next few videos, not going to do all of them today, but over the next few videos, we'll take a little part of this process and look at it a little more in depth. What I want to spend some time today is really talking about problem definition, because that's where you guys are going to be at this point, hopefully, in your processes. What exactly, we've got a client that's presented us with a need, something that's going to help us with the current health crisis, and right now our goal is to try to figure out, okay, what exactly is that, and how do we go about it, right? So we've identified a need. A need has been presented to us, and we're going to try to find solutions for that. And so what we need to do at this point is we need to go through the process of, okay, what exactly is this problem? What are the criteria? What do we need to solve it, right? Professor Knox mentioned some diameters that we need to make sure we achieve, and it's got to form an airtight seal with the face, and so a number of things there. At least that's for the intro class. And for the graphics class, you guys have got a different set of criteria there, and that's okay. So what is it exactly that you're trying to accomplish, and how do we know that we're going to accomplish it? Okay? It's really important that you understand that the design process is an iterative process. What that means is, I've drawn it here in a linear fashion, but it is not uncommon at all that we actually get to where we build something or we actually evaluate it, and that says, hey, wait, what exactly are we trying to do? Or, you know what, we've now got a different problem that's come up, something we didn't anticipate. We go back and we try to figure out what is that other problem, what causes it, what are some ways we can solve it, and then move forward. At any point, right, and sometimes I've heard the phrase, go back to the drawing board. That's the idea of, we built something, it didn't work, go back and try to figure out why didn't it work. Okay, so at any point, we could go back, maybe even from, when we start doing some brainstorming and try to come up with some other ideas, maybe at that point we say, oh, well, here's a really good idea, let's go learn a little more about that idea. Maybe that's easy to implement. Understand the design process is an iterative process. You're constantly going to be going back. It's not a linear process, and that's okay. And we talked earlier about plan for the design process. Here I've grouped several steps into this one point. You need to plan in your design process some additional time, if at all possible, to accommodate for this iteration. And you're probably not going to go straight through it the first time, and that's okay. We just need to know that and be aware of that. So be prepared to reconsider assumptions as they come up, as problems come up. So what you want to do at this point is you really want to try to define what exactly is your problem, what are you trying to accomplish. I would suggest, as a group, write down your problem statement. What is it that you want to do? And just be ready to change that as you go through, but at least it is a starting place. When you write your group report, your project report, there's going to be a section there called the introduction. The introduction is your problem statement in your group's words, not copy-pasted from my document. What did you as a group set out to accomplish? So you want to take a moment or two in the next few days and make sure that you as a group agree on what is your problem definition. Include constraints, include objectives, try really hard to balance between being too general and being too restrictive. Okay? And it's real easy to say, well, we're going to build, for my intro class, we're going to say, well, we're going to build the best mask we can build. Well, maybe that's specifically focusing on one specific solution. Maybe that's not actually what you're trying to accomplish. Maybe we take a step back and try to find a more generic solution. A good example of that I always like to point to is the space shuttle program. Whenever we were first designing space shuttles, right, which we don't even use space shuttles now, right? But whenever we first designed space shuttles, we understood that there was an issue with heat being generated on re-entry. And so this is a perfect example of writing a problem statement that's too specific. We knew space capsules were torched. They would burn up upon re-entry. They experienced too much heat. And we knew we didn't have the material that we could build these new space shuttles out of. The idea of the space shuttles, we wanted to be able to reuse them. And we didn't have a material that could be reused upon re-entry. The temperatures got too exceedingly high in order to do that. So there was actually an original problem statement. I've not actually been able to verify this, so I forget what source I pulled this from, so feel free to slaughter me in the comments if you like. But what I've been able to find is basically one of the original goals of this project was to try to develop this new fancy space-age material that could experience re-entry multiple times. The goal of the space shuttle is to develop a vessel that could be reused over and over again. To this point, capsules, once they came back to Earth, they got the astronauts home, but the capsule was fried. They wanted to develop a shuttle that could be used to go in and out of the atmosphere multiple times. So they wanted to develop a material, find this new material that could do that. Here's the truth of the matter. We never solved this problem. Let that sink in. We don't even use the space shuttles now. We've retired them. We never solved this problem. This is a perfect example of a problem statement that's too specific. At the end of the day, what are you trying to do? At the end of the day, you're trying to protect the astronauts first, protect the space shuttle second. The solution they came up with was a tiling system that's designed to disintegrate, and that through that disintegration process, it dissipates the heat away from the space shuttle and the astronauts. When the shuttle gets back home to Earth, if there's any remaining tiles, they could just be scraped off, and then a new set of tiles could be put on the space shuttle and sent back out. So again, what is it that you're trying to accomplish? Sit down as a group, talk about that, come up with a good problem definition. There's another example here in your notes. We could talk about, I've got to keep my video down to 15 minutes. So I'm going to try to finish out here. I don't want to spend a lot of time talking about research, but you do need to do some research. You need to go out and find what is the theory, what is the science associated with this problem. What are your restrictions, and maybe there's some solutions that already exist out there that we can make some recommendations on, or we could try to mimic, use as inspiration for something we can design. Right? So that's kind of this phase. Is the hope is at this point you guys are developing a problem statement and starting to put together ideas that exist already for maybe how to do that, and the hope is that will inspire you then to do some brainstorming to generate your own. Alright, so the last thing I'm asking you guys, normally I ask you to complete a design notebook. You're welcome to keep a design notebook to keep basically track of your thoughts and progress to the project. But one way or the other, each individual member needs to send me progress on how you've done on the project on a weekly basis. And these will be due every Thursday. Ask me if you have questions. I'm about to the end of it. There's my alarm. So I'm going to have to stop there. But email me, ask me if you have questions.